So we're given a graph y equals f of x, which is a strange situation because we're given a function, but not like we used to, an equation, but rather we're just given a graph. Remember that this is about numbers, so you can actually throw a grid on this and approximate the values. So the first thing we're going to do is we're going to take the opposite. How do we take the opposite of a graph? So how would we graph y equals -1 times f of x? So that means same x but opposite y, and that's exactly what's going to happen. This here is a 0. The opposite of 0 is 0. So everywhere where we have an x-intercept, the opposite of the graph will also have an x-intercept. And let's say this is like -2. So for this value of x, the y is -2 multiplied by -1. Now we're up to +2, and so on. We're just going to reflect these points. If this looks like 4, then the opposite is going to be -4. So basically, to get the opposite of the graph, we reflect the graph to the x-axis. Okay. Now let's go for the fun stuff. So how would we take the absolute value of a function? So what does the absolute value do? The absolute value of a number is the number itself if that number is positive or 0, and the opposite if a is less than 0, right? So what that means, wherever y is positive, we just leave it alone. The absolute value of y is the number itself as long as y is positive. Now what happens to the function's graph where the y values are negative? We take the opposite there. That's just like what we did here. The parts where the y coordinate is negative, we reflect to the x-axis. I call it folding because we kind of fold the graph up like a sheet of paper. And this trick can be applied for fairly simple or more complicated things. For example, if you have to graph f of x equals the absolute value of x plus 2, I'm in the habit of graphing first x plus 2 and take the absolute value of the graph, which means wherever it's positive, you leave it alone, and wherever it's negative, you reflect it to the x-axis. Or what about the absolute value of a parabola? Well, we can graph the original parabola, which has x-intercepts at -3 and 1. And then once we have that graph, we just take the absolute value of it, which means wherever the y-coordinate is positive, the point remains, and wherever the y-coordinate is negative, we take the opposite, or we reflect it to the x-axis. So this is how you take the absolute value of a graph. Thank you for watching.